Hello, I'm Ki-Joong Kim and I'm working in the NETL sensor team. Today, I'm presenting one of our technique, a scalable route for sensor production. Before beginning the presentation, I would like to introduce our team. Our sensor team here at NETL consists of experts in the field of materials science, chemistry, and sensor device development. We aim to improve the efficiency and the reliability of the existing sensor technologies for the next generation of energy power. Currently, we are exploring topics such as distribute the sensors and the sensor materials for energy application. So here are the team members for this event. I myself, BATTELLE research scientist in the research support team, Scott Crawford, Oak Ridge postdoc fellowship, and Michael Burdick as a NETL step scientist. Here is some information on the background for this project. Chemical sensors are interesting the topic in industrial and medicals, as well as the energy and environmental field. And the global market for chemical sensors is growing at a significant rate. Thus, it is important to develop a cost-effective techniques for developing sensors to provide to a wide range of customers. The metal-organic frameworks are very promising sensing materials because their tunable porosity and their chemical stability. On the right, you can see how you can engineer the porosity of the metal-organic framework to have high selectivity for variety of chemicals. However, the integration method of metal-organic framework as a thin films on the sensor devices is very limited to lab work right now because the current techniques are expensive, time-consuming, and have limited coating areas, which increase the cost of mass production. So for example, current method require specific chemical bonding such as self-assembly monolayers and requires long reaction time or requires the specific equipment sometimes and also even requires high temperature and high pressure. Therefore, it is crucial to um, develop techniques that are rapid, efficient, low cost, and versatile before commercialization of metal-organic framework-based chemical sensor system. Our technology enables the customers in the sensors market to significantly reduce the cost associated with reaction times, equipment, and the chemical reactant during sensor mass production. Our technique is to use the conductive metal oxide itself as a template and a hydroxy double salt intermediate for the MF thin film gloss. This procedure requires only about 20 minutes and room temperature. No specific equipment is required. Another big benefit is that since the growth only happens on the template, this technique use the 10 times, no, 10 thousands less the solvent than the existing techniques, which reduce the cost significantly for the chemical waste disposal. So our technique is very unique due to its patterning. It is also able to grow on the three-dimensional surface, such as fiber optics, and also able to grow on the loop surface and able to grow on the with a large scale. The comparing techniques for the MOF thin film fabrication include the servo-thermal method spin coating, layer by layer deposition, and electrochemistry. However, this competing method can suffer from long duration times, high equipment cost, inefficient to use chemicals, and the challenges associated with scalability. These are main drawbacks for the real applications. Now looking at the table, you can see in terms of preparation time, equipment, the chemical use, and coating areas, our techniques outperform all the other competing the methods. The chemical sensors are fastest growing the sensor market for industrial, medical, environmental monitoring, and defense and homeland security. The rising levels of pollution have supported the demand for the chemical sensor as well. The portable and wearable chemical sensor device also provide growth opportunities in the coming years. The last year, the chemical sensor market was valued at $22 billion and is now expected to reach a value of $33 billion by 2025 at a compound annual growth rate of 7.5 for next 5 years. Taking a look at the second graphic, it is evident that North America is expected to dominate the global chemical sensor market. The market in Asia Pacific is also expected to register the fastest growth. Moving on, the key players the profiled in the global chemical sensor market are Honeywell, BASF, General Electronic, Thermo, Fisher Scientific, and etc. In summary, we have leveraged expertise resulting in a new method that is very simple but very powerful to induce metal organic framework thin films on sensor devices. So this technique facilitated the mass production of the various sensor technology. Our approach is applicable to not only chemical sensor, but also catalyst, drug delivery, and membrane system. With proof of concept, sensor experiment completed, anticipated next step include partnering with companies in the chemical sensor industry for aid in reaching production the milestone. So we are now looking for the partners to collaborate on field testing for demonstrated performance in a real-world environment, the rational design for the specific sensor targets, the integration into the existing sensor platforms, such as optical fiber, quartz, crystal microbalance, and other sensor devices. So here is the contact information if you have any questions and or want to collaborate with us. Lastly, we would like to thank the DOE and NETL Fossil Energy Carbon Storage Program and Leidos Research Support Team. Special thanks to our technical transfer team, Jessica, Paula, and Caroline. Thank you so much for your attention. Be safe and be healthy.